So Christopher, we've got a Casio calculator here that doesn't work, is that true?
That's quite true, Gaz, yeah. I've turned it on, I'm pressing the buttons and we don't seem to be getting anything. Turn the calculator over and this is where the batteries should be, this is the supply. But what I've done is I've just brought 2 leads out so I can externally supply this calculator with a lemon.
Straight away I need to know what sort of working voltage the calculator needs to get to. What voltage were they when the batteries were in there?
Well, there was 2 little button batteries in there at 1.5 volts each.
Okay,
so
somewhere near 3 volts we're going to get. We're going to power this off lemons. Now you've already got one set up because you proved to me off camera how many volts would actually be present inside a lemon.
I certainly did. So we have a lemon and I've inserted a zinc nail.
Okay.
The zinc nail is the cathode and I've inserted a copper nail which is the anode.
So much like a lead acid battery back in the day, and what we've been taught at college is, and therefore we must have some sort of solution between them. What we're going to call the solution between those anode and cathode?
We're going to call this an electrolyte that's inside here, and what we've done is I've given it a little bit of a squeeze and a little bit of a roll so we can loosen the citric acid up. And now I'm going to put the crocodile clip, a negative onto the cathode, and I'm going to put the positive on the anode, and as you can see on the meter we have around about 0.9 volts.
Okay, is it AC or DC? I know the answer.
It's a DC voltage with it being a battery.
So if you rolled the lemon, it would be AC, would it? Because it'd be alternating. Is that the idea?
If I keep rolling this like that, no, it'll still be a DC supply.
Which makes logical sense because obviously the calculator was working on DC before we started. Well, that is not going to be enough electrical energy to power the calculator. So how many lemons are you thinking there we're going to need?
Well, we've got 0.9 and we need around about 3 volts. So I would suggest that we do another 2 lemons.
Okay, roll them around.
Roll the lemon.
Okay, yeah, in order to get it nice and juicy.
Nice and juicy, nice and juicy. There we go.
The next question is obviously people watching this is thinking, well, if we've got round about 1 volt from 1 lemon, how are we going to get to 3? So it goes back to your basic electrical science and principles. You've got to be thinking now, are we going to connect these in series or are we going to connect them in parallel? While you're thinking about that, you're going to get some more of these nails out. So 1 copper and 1 zinc in order that we can effectively make batteries from these.
So I'm going to put that one this way and that one this way.
Is it imperative you keep them as far apart as you can?
If we can, yeah, so that we can keep as much electrolyte going across the 2.
Is it hard to get hold of copper nails, or is that something that you found easy?
I found them an online retailer.
Does it offer next day delivery?
Does it offer next day delivery, yeah. We've got the 3 lemons there now, Gaz. They're quite easy to make and now they'll be hopefully coming into a battery. So we have to connect these up by some jump leads. Okay,
and are we going to connect them now? People have had time to think about it. Are they going to be connected in series to increase that voltage?
We're going to connect them in series, yeah, to get around about 3 volts. So what I'm going to do is I'm going to make it nice and easy for myself. So I'm going to go from this negative here.
Yeah, the positive of the next one. And we're going to leave effectively the end terminals to be our total voltage, which is in series, which we're hoping will be somewhere around about 3 volts. If we get to 3 volts, you'd expect what to happen to the calculator?
Well, I'm hoping that it's going to be working. So we'll just check it, the voltage.
So you're going across the 2 end terminals here.
I want to go on to the negative.
Let's see what we get.
I want to go on to the positive.
Oh, okay. That's really good maths as well.
It wasn't bad, that was it? Actually, I was quite lucky with that, yeah.
So they're all about 0.9 of a volt. We got to 2.7 volts. So it just means now you've got to replace where the instrument laid with actually where the battery connectors. And this was nice and simple. Obviously, these leads are permanently connected in as you bypass that battery. I'm hoping to see an energized classic Casio calculator. You recommend the FX range for your students?
The FX, our students use the FX range, yeah. The modern one.
Do many of them bring 3 lemons in to power it up, or are they actually... Oh, there's a good sign. Shall we do a simple maths calculation?
3 times 3.
Okay, let's see what that comes out as.
3 times 3 equals 9.
Okay, brilliant, yes. We can see the calculator is clearly working. We've connected in series our lemons in order to get somewhere near the 3 volts. We've called it an anode and a cathode, an electrolyte in between them, and we've used the citrus fruit here. Is there any other fruits that would also work for this?
We can use limes, we can use oranges, you can use potatoes.
Here's one for you, Chris. What happens if we happen to cut a lemon in half? I'm thinking I'm going to half the voltage. Now, we've got a spare one. Are we going to do it with a spare one?
We can cut the spare one,
It'd be interesting for people watching this to see what they think. I'm going for half a lemon and therefore half the voltage. Here we go. So we've got a bread knife. It's the best we could do at Lineside Studios. We're going to put our anode and cathode back into it.
Yeah, so we'll put another copper nail in here. And we'll put a zinc nail
yeah,
in
that's
here.
fine. Yeah,
should say.
okay. And now we're going to connect it across. And we're all going to see, folks, how I've got it dead right, that we're about half the voltage we started with on a lemon. So if you want to connect those up for me.
Onto the positive,
Yep.
onto the negative.
Oh, I'm wrong. So why am I wrong, Chris?
We still have an electrolyte that's inside the two conductors, the anode and the cathode, so therefore we'll still get the voltage.
So if we didn't want to buy 3 lemons, we could have obviously did it with slightly less lemons.
We could have saved some money and got to just half the amount.
Yeah, and unfortunately, they come in a bag of 4. That's all we had for. Absolutely brilliant. I think there's some learning there for everyone. But if you want to learn some more, and it looks remarkably like we've got maybe what we'd like to call a homemade capacitor, I'll check out the video on screen now.